Hi students, today we are going to discuss an important topic, that is dipole field. Okay, today we are going to discuss dipole field. So how we can find the electric field at a point due to a dipole. We know that what is a dipole. Dipole means two equal and opposite charge separated by some distance. That arrangement is called a dipole. And also we know that the total charge of a dipole is 0. The total charge of a dipole is 0. Okay. So here we are going to find out the dipole field in two cases. One, the point on the axis of a dipole, and another one, the point in the equatorial plane of a dipole. In two cases we are going to find out the electric field due to a dipole. Okay. Now we are going to discuss about the electric field at a point on the equatorial plane, okay, of a dipole. Okay, this is the second case we are discussing. So we are finding the electric field at a point on an equatorial plane of a dipole, that we are going to discuss now. So we consider a dipole. So this is a dipole, okay, having length 2a is the length of a dipole. 2a is the length of a dipole, and here this is plus q charge and here is minus q charge. Two charges, plus q and minus q charges. Okay, and dipole length of this dipole is taken as 2a. And it have a dipole moment. Dipole moment of the dipole is P vector is equal to Q into 2A. Q into 2A, or we can write it is P vector is equal to 2QA. 2QA, that is the dipole moment. Okay, and the direction of dipole moment is from, the direction is from negative to positive. So this is the direction of dipole moment. This is the direction of dipole moment is from negative to positive. So I consider this point is A and this point is B. So we consider a dipole of dipole moment P, and direction of dipole moment is from A to B. This is the direction of dipole moment. Direction of dipole moment is from negative charge to positive charge. So this is the direction of dipole moment P vector. So we consider a point on the equatorial line from the center of a dipole. So this is the center of a dipole, or from the center we consider a point P at a distance r. Okay, that point P is the equatorial plane of a dipole. So we consider a point P at a distance r from the center of a dipole. That point P is at a equatorial plane of a dipole, or equatorial line of a dipole. So we are going to find out total electric field at this point. So we are going to find out the total electric field at this point. Okay. So due to minus q there will be a electric field at the point P. Due to plus q there will be electric field at a point P. So we are going to find out the total electric field. So we draw a line from P to minus q and P to plus q, that is P to A and P to B. We draw a line, and this angle we consider is theta. Theta is the angle, this angle. Okay, clear? So first we are going to find out the electric field at the point P due to plus q charges, and after that we are finding electric field at the point due to minus q charges. Okay, so we need to find out total electric field at this point P. Okay, and the direction of the dipole moment, the dipole is from A to B. First we are going to find out the total electric field at a point. We are going to find out the electric field at a point P due to positive charge, that is we are finding E plus. E plus is electric field at a point P due to the positive charges. E plus equal to, so we know that the general equation to find electric field. Electric field E is equal to 1 by 4 pi epsilon 0 Q by R square. That is the equation for finding electric field at a point. So here we are finding electric field at a point P due to this plus Q charges. So E plus equal to 1 by 4 pi epsilon 0 Q divided by the distance from B to P that we don't know, so we consider this BP square. BP square. BP square. We are getting BP square. And the direction of electric field at the point P is in this direction. Electric field is in this direction. Okay, direction of electric field at the point P is in this direction. Direction of electric field at the point P is in this direction. This is the direction of electric field E plus. That means it is directed along BP. The E plus is directed along BP. Okay, so we have to find out the value of BP. Okay, so finding the value of BP, we consider right angle triangle PAO. For finding the value of BP, we consider right angle triangle PAO and apply the Pythagoras theorem. Apply Pythagoras theorem, then we can find the value of BP. BP square is equal to what we are getting. BP square is equal to R square plus A square, because this is center, so this distance is taken as A, and this distance also taken as A. So by applying the Pythagoras theorem, we get BP square equal to R square plus A square. So this equation changes to E plus is equal to 1 by 4 pi epsilon 0 Q divided by R square plus A square, and it is directed along BP. It is directed along BP direction. Okay, it is directed along BP. So this is equation number 1. Next, we are going to find the electric field at the point P due to the minus Q charges, that is written as E minus. E minus is electric field at a point P due to the negative charges, that is written as, that is equal to 1 by 4 pi epsilon 0. 1 by, here we are taking the magnitude only. So E minus equal to 1 by 4 pi epsilon 0 Q divided by this distance. Here E plus and E minus we are taking magnitude. Okay, the E plus value we got, it is 1 by 4 pi epsilon 0 Q divided by R square plus A square. That is equation number 1. That is acting along BP direction. That is the E plus. E plus value is E plus equal to 1 by 4 pi epsilon 0 Q divided by R square plus A square. That is equation number 1. It is acting along BP direction. Now we are finding the electric field at a point P due to negative charges. That is E minus equal to 1 by 4 pi epsilon 0 Q divided by this distance, that is AP square. And the direction of electric field at a point P due to this negative charge is along PA direction. Along PA, so this is the direction of E minus. It is along PA direction. It is along PA direction. And from the figure we get the value of AP square. So AP mean root of R square plus A square by using the Pythagoras theorem. So we can write E minus is equal to 1 by 4 pi epsilon 0 Q divided by R square plus A square. Okay, E minus equal to 1 by 4 pi epsilon 0 q divided by r square plus a square, that is along PA direction. Okay, so we get the value of E plus the magnitude of electric field at a point P due to the positive charge is E plus equal to 1 by 4 pi epsilon 0 q divided by r square plus a square, that is along BP direction. And if at a point P due to the negative charge is E minus equal to 1 by 4 pi epsilon 0 q by r square plus a square, that is along PA direction. These two represent the magnitude of electric field. From these we can found that magnitude of electric field both E plus and E minus are equal, that is equal to 1 by 4 pi epsilon 0 q by r square plus a square. So here E plus is acting in this direction, E minus is acting in this direction. So the resultant of the electric field will be is in this direction. So we consider E plus and E minus are vectors. So applying the parallelogram law, so the resultant vector, so E equatorial, the total electric field will be in this direction, that is opposite direction of the dipole moment. E equatorial, the total electric field at point P at this point, that means total electric field E at the point P is in this direction, that is in the opposite direction of the electric dipole. Okay, so here we are going to resolve. So this angle is theta, so we can write this angle is theta, and this angle theta means this angle also theta. Clear? So this angle means this angle also theta, and this angle theta means this angle also theta. So we can resolve E plus into 2 component, E plus into 2 component. One is E plus cos theta and other one is E minus sin theta. The E plus sin theta. E plus, we resolve into one, E plus cos theta, another one is E plus sin theta. The direction of E plus sin theta is in this direction. E plus sin theta is in this direction, and E plus cos theta is the same direction of the equatorial net electric field. E plus cos theta is in the direction of net electric field, total electric field, that is along the E equatorial. Okay, and again we resolve E minus into 2 component, resolve E minus into 2 component. When we are resolving E minus into 2 component, we get E minus, we are resolving E minus into 2 component. One is E minus cos theta, another one is E minus sin theta. We resolve E minus 2 component, E minus cos theta and E minus sin theta. The direction of E minus sin theta is in this direction, and E minus cos theta is the same direction of the net electric field. E minus cos theta and E plus cos theta is the same direction of the net electric field. And E plus cos theta is acting upward direction from the point P, and E minus sin theta is acting downward direction from the point P. And we know that the magnitude of E plus and E minus are equal, so we can consider E plus sin theta and E minus sin theta value are equal. E plus sin theta and E minus sin theta component value are equal. They are acting opposite direction, so the net effect due to E plus sin theta and E minus sin theta will be cancel each other. Here E plus sin theta is acting upward from the point P, and E minus sin theta acting downward. The magnitude of E plus sin theta and E minus sin theta are equal, but they are acting opposite. So the net effect due to E plus sin theta and E minus sin theta will be cancel each other. But E plus cos theta and E minus cos theta are acting the same direction. E plus cos theta and E minus cos theta is acting along the same direction. So the net electric field E equatorial is equal to E minus cos theta plus E plus cos theta, but we know that the net electric field is in opposite direction of the dipole moment, so we get minus of P n cap, because E equatorial, this is a vector represent E vector, E vector is equal to minus of E minus cos theta plus E plus cos theta p cap, because the net electric field at the point P is in the opposite direction of the dipole moment. The magnitude of E plus and E minus are equal, so we can write E equatorial equal to minus 2E plus cos theta into p cap. Here p cap represents the direction of E equatorial. So here actually minus p cap, that means E equatorial, the resultant electric field is in opposite direction of the dipole moment. That's why it's negative sign curve. So we substitute the value of E plus. We know the value of E plus. E plus is, we know that E plus value is E plus equal to 1 by 4 pi epsilon 0 Q divided by R square plus S square. So we are substituting in this equation, so we get E equatorial is equal to minus 2 into 1 by 4 pi epsilon 0 Q divided by R square plus A square cos theta p cap. So this is the E equatorial. So E equatorial is equal to minus 2 1 by 4 pi epsilon 0 Q divided by R square plus A square cos theta into P. Here we have to find out the value of cos theta. So we consider any of the triangle PAO or PBO. So we have to find out the value of cos theta. We consider the triangle PAO or otherwise PBO. So we can write, if we consider triangle PAO, we can write cos theta is equal to adjacent side by hypotenuse. So we get A divided by root of R square plus A square. So cos theta is equal to, from the triangle PAO we can find cos theta is equal to adjacent side by hypotenuse. Adjacent side is A, hypotenuse is root of R square plus A square. So we substitute the value of cos theta here, we get E equatorial is equal to 1 by 4 pi epsilon 0 minus 1 by 4 pi epsilon 0, okay, Q 2Q divided by R square plus A square into, what is cos theta? Cos theta value is this one, A divided by root of R square plus A square p cap. Okay, then we are going to rearrange this equation. Got the equation E equivalent is equal to minus 1 by 4 pi epsilon 0 2Q A divided by R square plus A square into root of R square plus A square whole raised to P. Okay, here I am going to rearrange this equation like this. This is a rearrangement, so we can write 1 minus 1 by 4 pi epsilon 0. We know that 2Q into A. 2Q into A is the dipole moment, so we can write as P divided by, and the denominator is R square plus A square into root of R square plus A square. So this is the denominator. I am going to rearrange the denominator. So I am going to write like this, R square plus A square whole raised to 1 into, and this is the root of R square plus A square. I can write like this, R square plus A square whole raised to 1 by 2. So we can write by using the equation x raised to A into x raised to B. What it is? It is x raised to A plus B. By using this equation we can write this, that is equal to R square plus A square whole raised to 3 by 2. So instead of this I am going to write R square plus A square whole raised to 3 by 2. So this equation changes to E equivalent equal to minus 1 by 4 pi epsilon 0 P by R square plus A square whole raised to 3 by 2 P cap. Why is a negative sign? Negative P vector, because the E equatorial, the electric field at a point P due to this dipole is in opposite direction of the dipole moment. So E equatorial equal to minus 1 by 4 pi epsilon 0 P divided by R square plus A square raised to 3 by 2 P cap. But here we consider the length of a dipole. Here we consider the length of a dipole is less than the distance r. So we can, this is the equation for finding the E equatorial at a point P due to this dipole. This is the vector form. Suppose if you are writing the magnitude, here there is no sign. Okay, so this is a vector from E equatorial equal to minus 1 by 4 pi epsilon 0 P divided by R square plus A square raised to 3 by 2 P raised to P cap. Okay, so here we consider one case. Suppose the length of a dipole is less than the distance, that is A is very less than R. A is very less than R. So the denominator of this equation, that is R square plus A square all raised to 3 by 2. We can write it like this, because A is very less than mean A square value is less. So we are neglecting the value of A square. So we get R square all raised to 3 by 2, that is equal to R cube. So instead of this, if you consider the condition, that is A is less than R, that is dipole length is less than the distance R. So we get R square plus A square to 3 by 2, we can write as R cube. So this equation changes to E equatorial is equal to E equatorial is equal to minus 1 by 4 pi epsilon 0 1 minus 1 by 4 pi epsilon 0 P by R cube P vector. So this is the equation for finding electric field at a point on equatorial plane of a dipole. Here E equatorial equal to minus 1 by 4 pi epsilon 0 P by R cube P cap. Here negatives and negative indicate the negative P vector. P cap represent E equatorial is opposite direction of the dipole moment. Suppose that if you consider magnitude, if you consider magnitude of equatorial is equal to magnitude of equatorial equal to 1 by 4 pi epsilon 0 P by R cube. If you consider magnitude, this will be the equation 1 by 4 pi epsilon 0 P by R cube. P is the dipole moment. The value of P is 2qa. Okay, here Q is a charge, A 2a is the dipole length. So this is about the electric field at a point due to the equatorial plane of a dipole. We are going to discuss the relation between E axial and E equatorial of a dipole. So the relation between electric field at a point on the axis of a dipole and electric field at a point on the equatorial plane of a dipole. That is what is the relation between these two. So here we consider the magnitude of E axial is equal to the magnitude of electric field at a point due to dipole on the axis. So the E axial is the electric field at a point on the axis of a dipole, that is given by the magnitude we are considering E axial equal to 1 by 4 pi epsilon 0 P by R cube. P by R cube. So this is the 2P by R cube. Okay, E axial equal to 1 by 4 pi epsilon 0 2P by R cube. That is the equation for finding the electric field at a point on the axis of a dipole. This is the magnitude. Okay, in vector, actually the E axial is in the same direction of the electric field at a point on the axis of a dipole is in the same direction of the dipole moment, but here we consider only the magnitude. E axial equal to 1 by 4 pi epsilon 0 2P by R cube. That is equation number 1. Next we consider the magnitude of E equatorial, electric field at a point on the equatorial plane. We consider only magnitude, so we get 1 by 4 pi epsilon 0 P by R cube. P by R cube. E equatorial is equal to 1 by 4 pi epsilon 0 P by R cube. That is equation number 2. Divide these two equations. E axial by E equatorial. E axial by E equatorial. What you will get? If you are dividing these two equations, what you will get? That is 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 2p by R cube divided by 1 by 4 pi epsilon 0 P by R cube. So 1 by 4 pi epsilon 0, 1 by 4 pi epsilon will be cancelled, P will be cancelled, R cube will be cancelled. So we get E axial per E equatorial. E axial by E equatorial is equal to 2. That is, we can write E axial by E equatorial is equal to 2. That means, so we can conclude E axial is equal to from this we can write E axial equal to 2 times of E equatorial. So E axial rectified point on the axis of a dipole is 2 times of rectified point on the equatorial plane. That is E axial equal to 2 into E equatorial. Clear? So this is the relation between E axial and E equatorial.
She's waiting for love.